Okay, so this is how we're doing this now, guys. So a logarithm is just another way of writing exponents. The logarithmic form is log with the base b of a equals x. In exponential form, that becomes b to the x power equals a. So it creates a circle. So if you start with log base b of a equals x, to change it from logarithmic form to exponential form, you start with b and you circle to the x, and that becomes the exponent, and then equals whatever a is. So for the first example of log base 3 of 9 equals 2, to rewrite it in exponential form, you start with the 3, and that's the exponent it gets, so it's 3 squared equals a. So then it circles back over to the 9, so 3 squared equals 9. So for number 2, you start with the 7, you circle to the 0, so 7 to the 0 power equals 1. So for 3, circles this way and back up here. So 4 to the negative second power equals 1 over 16. And then for 9, it's 9 to the 3/2 power equals 27. And there we go. So that's how you change from logarithmic form to exponential form. Now to go backwards, it works the same way, and you go in a circle form. So you start with the 14, and you go to the 196. So 14 is the base. So log of 14, and then the 196 goes here, and equals the exponent. So your base of your exponent is the same as the base for your logarithm. Then it equals a, which goes there, and then 2 is what it equals in the equation. So for 3, that's your base. This is b. So log base 3 of 81 equals the exponent, so equals 4. Then this one. So now it's log base 2 of 1/8 equals the exponent of negative 3. And then for number 8, it's log base 8 of 16 equals the exponent, so 4/3. And that's how you convert from exponential form to logarithmic form. All right? So the next part of this is the common logarithm. So common logarithm is a logarithm with the base 10, and instead of writing it as log base 10 of x, because it's the common one, we don't write the base, and we just write log of x. If you see this, you know that this base number is automatically 10. Okay. So to evaluate logarithms, if you have log base 7 of 49, your first step is to rewrite it, but set it equal to x. And then you change it from log form to exponential form. So you do 7 to the x power equals 49. And then you have to make 49 into a base of 7, so that it becomes 7 to the x power equals 7 squared. And now we can go back to what we learned with solving exponential equations, and since they both have the same base, the exponents are equal, so it becomes x equals 2, and then that's your answer. So for this one, set equal to x, and then 3 to the x power equals 27. So then 27 with a base of 3 is 3 cubed. So because now they have the same base, their exponents are equal. So x equals 3. Okay. Now this is the common base one. So remember that this base is 10. So if you want to write a little 10 in there, you can. Then equals x. So 10 to the x power equals 100. So 10, we need a base of 10, which this is 10 squared. So now that the bases are both 10, our exponents are equal, so x equals 2. All right, and then we can just keep going. So we have 12 to the x power equals 1. And remember, to get 1, when you're talking about bases and exponents, your exponent has to be 0, so this becomes 12 to the 0 power. So then in this instance, x equals 0. Set that equal to x. So 9 to the x power equals 1 over 81. And then this is a fraction, so we know we have to have a negative exponent. So we have 9x equals 9 to the negative second power. So now x equals negative 2. Okay. All right, and this last one in this section. So we have 64 to the x power equals 4. Okay. So this time, our base with our exponent is smaller than our answer. When that happens, your exponent is a fraction, which we haven't really talked about yet. So we're actually just going to say that this one is no solution for now. And we will come back to it when we learn about exponents that are fractions. So the change of base formula is when you have to evaluate a logarithm that does not have the same base. Okay. And the change of base formula of log of base b of a is the log of a divided by the log of b. Okay. So in this first example, we have log base 16 of 64. Okay. So if we're going to use the change of base formula, we write it as the log of 64 divided by the log of 16. Okay. At this point, you just type it into a calculator or into Desmos and get the answer. Alright, so this one is 1.5. And if you're using calculators and Desmos, make sure you put parentheses around these numbers, or else you're not going to get the correct answer. Okay. So for these ones, we'll just set them up, and then you can type them in a calculator on your own. So this one becomes log of 94 divided by log of 10. And then we'll come back to that in a second. Now this one is a little trickier, because this one we can use exponential form, but we're going to use the change of base formula. So it's log of 1 over 36 over log of 6. Make sure those are in parentheses. And then the last one becomes log of 136 divided by log of 4. So let's get the answers for these. All right, so this one is 1.97. And this one is negative 2. And the last one is 3.54. All right, so that's how you use the change of base formula. And that is all of the notes for the intro to logs.